Hi, I'm Daniel and this is Ashville. Today we're rescuing the flooded landscaping of a £15 million house that was just completed. This beautiful detached 12,500 square foot home on the outskirts of London has recently been fully renovated, internally and externally. We did a review of it. Click here to watch that video. In the summer, all looked to be well, but when winter started, a problem arose. It turns out the contractor that built this area misjudged the water table, and when winter set in and it began to rain, the entire rear garden became bogged down and flooded. The developer of this property, Andrew Southern, has a group of companies. Now, this entire project was designed and built around showcasing the capabilities of those companies. So when the issue arose, it was paramount that it was addressed and rectified immediately. However, this problem created an opportunity. It's one thing designing a space on paper, it's another thing entirely living in it and using it. At this point, Andrew had operated the show home for almost a year. So we decided to put our heads together and redesign the entire space to create somewhere which was high-end, great for entertaining, and accurately reflect the capabilities of his businesses. Before contemplating any of the pretty stuff, we needed to assess what was in place and concentrate on getting the infrastructure right first. On a lovely sunny day like this, everything looked perfect. But once it rains, all bets are off and it's a completely different picture. So the starting point was the drainage, as the green areas were basically a swamp. This was caused by a lack of irrigation, and the problem compounded as water in other areas such as the fire pit seating was diverted to the lawn also. On the subject of water, the external tiles were laid incorrectly, resulting in uneven surfaces and improper falls, which diverted rainwater to the swimming pool instead of a drainage system. Water was also backing up in pipes between the outdoor swimming pool and property, which needed to be investigated. Electrical cables were run above ground and scattered across the turf. The external bench seating was not properly treated and was constructed using poor quality materials. Timber used on the external kitchen was not properly treated, leaving it completely exposed to the elements to rot. Both external showers were leaking, and Andrew reported lots of insects coming into the pool from the vegetation close by. So unfortunately, due to the amount of work which needed to take place, everything needed to be demolished. So we thought it best to make a start on the demo while carrying out investigations which would enable us to formulate a plan. To add to the pressure, we have 4 weeks to complete because Andrew is leaving the country and he has a tenant moving in for the entire summer. The previous seating was made from block work, so it was easy enough to dismantle. Once we removed the tiles, we needed to also remove the adhesive beneath it to get the levels back down to the structural slabs. The blocks, tiles and render were kept segregated and removed from site first, as these materials could be processed to create recycled aggregates. Click here to watch a video where we explain how to create recycled aggregates and how a crusher works. Our plan to deal with the large amount of water here are 2 soakaways. But in order to do these, we need to understand the ground conditions. The best way to find out is a borehole. So we are going to dig 3 of these, each 6 meters deep. A borehole is a narrow shaft vertically or horizontally drilled into the ground. They're used for extracting oil, gas, or water, or geotechnical investigations like we're doing here today. Due to access limitations, we had to ensure a moderately sized rig was used for these boreholes. This is a mini rig. It's powered by a diesel engine driving a hydraulic pump. The support legs, called balance beam, are installed to ensure the machine can remain upright and at the correct angle for drilling perfectly straight down. The rig is capable of 2 types of drilling, a hammer down and spinning auger. The drill bits, called flights, come in 1 meter and 2 meter lengths, are 125mm wide and are locked in with the U-pin. The process is to drill down 1 meter, then bring the drill back up. At that point, attach another flight and go down another meter. Once you get to 4 meters, you only need to bring 1 meter out of the ground, leaving in 3 meters. Then attach another flight between what was previously flights number 1 and 2. You can then push on and keep drilling. At each level, when coming back up to ground, we take what is called a disturbed sample and send it to the laboratory for testing. Borehole number 1, we have clay until we hit 1.7 meters, and then we have sand. Borehole number 2, we have clay until 2.8 meters, and then we have sand. Borehole number 3, we have clay again to 2.8 meters, and then we have sand. It's time to start the excavation in the main area. We remove the grass first and keep it as segregated as we possibly can from the soil. We do this as the grass can be taken to a green waste facility where it can be recycled to create compost, and this is not possible if it's mixed in with soil. It's exactly the same the other way around, as facilities which accept soil do not want it mixed with grass, as this can affect the stability of the land reclamation work. With the borehole results, we can make a plan for the 2 soakaways and their trenches, locations and depths. Soakaway 1 will be the larger of the 2 and closest to the property. Soakaway 2 will be to the rear of the garden, where Andrew has now decided he would like a 5G football pitch. In the tiled areas, we're going to fit a drainage system which runs along the perimeter of the property, and the tiles, which will now be a 2-color contrasting design, will divert rainwater to this instead of the swimming pool. We're going to create a new seating area with magic curved seating, which looks like it's floating to surround a new fire pit. The outdoor cooking space will be redressed with timber to match the new floating seating. We're going to excavate close to the pool, find out why the water is backing up in the pipes, rectify and build a dwarf wall close to the pool to manage the creepy crawlies. While doing that, we're going to run new cables in ducts underground, create a new sundeck, and create a bespoke 1-of-1 concrete diving board. The scope of works has grown significantly since we were engaged on the project, so the 1-month deadline became an almost impossible task, as when sequencing works, we need to take into account the curing time of concrete, which basically means how long it takes to dry before it reaches its design strength, which is 28 days. We also need to consider specialist material availability and bespoke fabrication lead times. So we created a project timeline of a best case scenario if all went according to plan, which it never does. Sequencing works day by day with no room for error, starting with the soakaway. What you can see here are the markings for the trenches we are about to start excavating. At the shallowest point at the beginning, these are going to be 300 mil deep, and they're going to be as deep as they need to ensure we have a gradient going to the soakaway. Once they're excavated, we're going to put a membrane inside. We're going to put 10 mil shingle. We're then going to have a perforated pipe, which is basically a pipe with loads of little holes in it. We're going to put 10 mil shingle on top of that, and then we're going to close it off. A soakaway is basically a buried underground drainage feature which helps manage surface water infiltrate into the ground, as opposed to trying to discharge into a sewer system, which is not allowed in the UK. The reason for this is the sewer system was designed for waste, and connecting rainwater would most definitely overwhelm it. The soakaway at its deepest point will be 4 meters, and we'll have staggered levels like benches, which you may see in a quarry. Once filled with material, the shape will act as a funnel, channeling water which has come from the surface above, and the trenches with perforated pipe to join with underground water. The level where I'm standing is just over a metre. Now we hit the water table at 3 metres and we have gone another metre down to 4 metres. So we're just using that long reach arm to its maximum potential here, trying to clean out the bottom of it. But what's not helping us is that it started raining. Simultaneously, another team have started work on the dwarf wall close to the swimming pool. We've used the existing slab and are fitting concrete blocks. In the void of the blocks, we're going to drill the slab, fit resin, rebar, and then pour concrete to strengthen and tie it all together. Once the concrete is cured, we'll return and apply a specialist finish. We are now going to start the work in the football pitch area. We're going to take the entire section down by 300, and then we're going to begin the soakaway works. In total, we removed 300 cubic meters of earth and soil. That was 25 full grab lorry loads. It's time to start filling the first soakaway. Here we are using construction aggregates, which are the most mined product on the planet. There are 2 forms: primary aggregates, which is extracted from pits and quarries and processed, and recycled aggregates, which is created from demolition waste. They range in size and capability. A few examples of construction aggregates are sand, gravel, and crushed rock. We're going to start with an oversized stone, which is 28mm to 85mm with no fines. Now, no fines means it doesn't have the very small particles that look like sand or dust. This is going to fill 3.5 meters of the 4-meter deep soakaway. Next, we're going to build up 300mm with a 10mm shingle. Now, this is also known as gravel. Then a layer of geotextile membrane, and then 300mm of lovely topsoil, which we have saved from the 400mm excavation in the football pitch. Our layered gravel soakaway improves natural drainage, referred to as infiltration, by increasing the consistency at which water can seep through. Gravel is a uniform size, and the gaps between allow for consistent water filtration, as opposed to soil particles, which are a lot more dense and slow drainage, creating waterlogging. Our smaller size stone finely filters, allowing a gradual release, and as we get deeper, the larger stone facilitates increased flow to rejoin underground water and the natural water cycle. On the football pitch, we have a slightly different plan. We're going to start to fill the soakaway in the same way, with the oversized stone, and at that point everything changes. Now we're going to have the 10mm shingle, but only build up by 100mm, and then we're going to put a geotextile membrane across the entire football pitch area. Next, we're going to have a 6 to 20mm material, which is going to build up by 250mm, and then we're going to have a 2 to 6mm for about 50 to 100mm, and then no soil. At that point, the specialist 5G football pitch contractor will take over. A few of the areas were a little bit low, so we're building up with additional material. We're using the roller now to compact and stabilize, increasing the density and load-bearing capabilities to prepare for the next layers of material. We use geotextile membranes between the material layers to provide separation and at the same time filtration and reinforcement. It prevents finer material from mixing with others, which could cause clogging in drainage systems and improve structural stability. We use material with no fines at different levels in the material build-ups, depending on what will be at ground level, as the absence of fines increases permeability and allows water to seep through more easily, preventing accumulation and improving drainage. The soakaway and the majority of the groundwork are done, but we are not going to start the turf yet. We're going to leave that till last because we're going to have to track over it and make damage. The next part is the floating seating we're going to be creating in the hot tub and fire pit area. In order to create the illusion of floating seating, we need to create a structure strong enough to support a cantilever. We start by creating a 300mm base in reinforced concrete. We will tie this into the existing slab by drilling, fitting resin and then rebar. Once this is dry, on top we'll pour the backrest, which will be angled at the top section. At this point, the L-shaped profile of the base will be covered in soil, which will act as a balance weight. Steel will be fabricated, fixed into the backrest just before the angled section begins, and then the steel will be clad in timber. To create the mold, we're going to use a mix of metal formwork and ply. The metal formwork will be on the straight areas and the ply will be in the curved and more difficult sections. This is a C40 concrete, which is generally used for structural support beams, multi-story buildings, and construction depots with high HGV traffic. Simultaneously, while preparing to pour the second part of the seat, we removed the section close to the pool to investigate the blockage. We found that the 4-inch underground pipe had actually collapsed. This was replaced, protected, and the levels built back up to prepare for concrete, which will be poured at the same time as the second part of the seat. We're now fitting the formwork to pour the backrest of the seat. We will again be using C40 concrete for both the ground section and bench. We're using a vibrating poker to remove air bubbles to ensure consistency and strength of the concrete is not compromised. We can remove the molds, but the bench base and backrest will need 28 days before we can begin the next stage of works, which actually works perfectly because it gives us time to template the floating seating section. Once we have the dimensions, the work itself will be done in a workshop where the steel will be laser cut, welded, and galvanized. Galvanizing is applying a protective coat of zinc to the steel to prevent rusting. The work on the 5G pitch is about to start again.
At first, we need to remove the timber edging. There's going to be a new 4x4 post going all the way around. Now, this is going to be used as a level. So the material is going to be spread throughout and then compacted. On top of this, we're going to have a shock pad. And then on top of the shock pad, we are finally going to have the turf. The turf is going to be finished with a sand and rubber infill.
Not only can the treated timber post be used as a level, but also as a threshold and firm fixing point. They're set using a sand cement mix, secured to each other with screws, and must be completely level as they will act as a reference point for the next stages of work. Back over to the house, it's time to start the perimeter drainage channel. The system comes in lengths, which we cut and join where needed. We excavated the channel, used a sand cement mix to fix, and a spirit level and rubber mallet to ensure it's all positioned correctly. The tiles will then be fitted to divert towards this, and the rainwater will go down the linear area here, travel through the pipe and go to the existing rainwater management system. To finish it, the tiles will go over the concrete, over the drainage system, and all you'll see will be the linear grill. This is a bespoke one-of-one concrete diving board. We had this designed by a structural engineer as it starts before the pool and cantilevers over it without any supports whatsoever. We created a standalone video for this. Click here to watch it.
The paving is about to start. Now this is the edging and it has a bullnose finish. We are starting in this area because we still need to do some work around here. Now we are using a sand cement water mix and we are applying a slurry primer to the back of this, putting it in place and then ensuring it is level.
We started this process with string lines to mark up and plan the layout of these 20mm thick porcelain tiles. The darker tile will populate the edges and steps, and the lighter tile will fill the mass area centrally. We use 7mm spacers, a spirit level, and a rubber mallet to compact. A bullnose finish is a rounded edge from the top to the bottom of the side profile. This enhances the aesthetic appearance and increases safety as sharp edges are removed. It's time to start the work on the fire pits around. The below ground build-up will be engineering bricks, and this will be followed by 3 courses of concrete blocks, which will leave a void for circulation and drainage. The fire pit unit will sit on these blocks. Engineering bricks will be used again as a top course surrounding, and the entire unit will be finished like the backrest of the bench and the pool dwarf wall.
The area around the hot tub is a labor of love, and attention to detail is of paramount importance. When you sit in this area, in your eye line, you can see a raised level and you can see bullnose edges. Now, in order to continue that detail, we couldn't use the edging tile because it wasn't wide enough, and we didn't want to have loads of different joins here. We wanted one tile. So we've had to order a 60 by 60 tile from the same range as the edging tile. That should fit nicely right here. Now on one side, the the side which is facing the hot tub, we have a nice square edge which can finish flush. If you have a look over here, we can add one row of mosaic tiles and then we can finish it with a sealant. However, on this side, because when you're sitting down within your eye line, you can see the stairs, we need to replicate that finish. So we're going to measure this exactly and take it to a stonemason, and we're going to create a bullnose finish on this side, but ensure that we measure so the riser tile here, the top tile, just slightly overlaps and replicates what's going on the stairs. Here it is, back from the stonemasons with the bullnose edge. Perfect. Now we can fit the tiles in this area.
Back over to the 5G pitch, where we're compacting and the final thin layer of material is being laid. The term 5G means this is a 5th generation design. All of the designs and specifications are slightly different. The main difference between 4G and 5G is that 5G has rubber infill. A shock pad is an essential part of a 5G football pitch as it provides cushioning for falls to reduce injuries. Other than the size, this specification is a FIFA equivalent, similar to what most Premier League football clubs would have at their training grounds. The shock pad comes in large rolls and is rolled out like carpet underlay. Nails and string line are used to line up, and a Stanley knife to cut away anything surplus to requirements. Then it's time for the turf, which is a synthetic artificial grass. This is rolled out like carpet and altered in the same way as the underlay. Between the joints of the turf, a joining strip is laid and nailed into place. Specialist adhesive is mixed and applied with a trowel. Then turf overlaps on each side and forms a bond with the adhesive. Once the turf is laid, the markings are cut out. The pitch marker lines also come in a roll, but needed to be cut down into 100mm strips. The touch line and halfway line are relatively simple as they are the outline of the pitch, but as this is not a standard size, the penalty area needed to be calculated as a percentage, so it was proportionally the same size as it would be on a regulation pitch. This spreader is then used to distribute the kiln dried sand. Then the power brush is used to brush it in. The same process is followed for the rubber infill. The rubber infill, also known as SBR rubber, is generally made from grinding up and granulating recycled tires. The purpose of rubber infill is to keep the fake grass fibers upright, to replicate natural playing characteristics of real grass, and provide additional cushioning. Meanwhile, back over at the seating area, we are tiling.
I hold.
The main tiling is finished and we're now having a tidy up. All that remains are small upstands, some very fidgety bits and some snagging. We're spreading the soil evenly so we can calculate how much additional material we're going to need to import.
The client has chosen a matte concrete finish for the bench, fire pit and dwarf wall. Now we can't just apply this because one, it won't look good, and two, it won't last. There's a process in place, but we have a different application process for the bench than we have for the fire pit and dwarf wall. For the fire pit and dwarf wall, we first need to apply this primer. Now this will prepare it for the next layers and it's also going to give it waterproofing capabilities. We then use this mesh rendering system. This will give it nice straight angle corners and prepare for the next layer.
This is fitted with a cement-based product. Two coats are applied to create a smooth surface, stability, and limit movement. This is carried out on both the dwarf wall and fire pit.
Once that is dry, we apply the painted matte concrete finish, let that dry and apply 2 layers of sealant. As the concrete bench is made from reinforced concrete, we will not have any movement whatsoever, so we do not need to use the mesh. However, we will use the primer. After the primer, we will use 2 coats of the cement product. Then we will apply the painted matte concrete finish and follow up with 2 layers of sealant.
The render is now being prepared for the matte concrete finish. We're cleaning the surface of dirt and form sanding to remove any build-ups to ensure the desired shape is achieved.
We are about to start bulk earth shifting again. Now we're excavating at the front of the property where we're going to have new turf. We're bringing that material to the back. We're going to spread it over this entire area, ensuring we cover the L-shaped profile of the bench seating, because this is part of its structural strength. Once we've done all of this, we know exactly how much topsoil we will need to import. Now the topsoil we import will be a British standard with manure, which will provide nourishment for the new turf. While doing this, we will use this paving block and we will create a clear divide to let gardeners and landscapers know that when mowing the lawn, you stop at the turf and do not go onto the 5G pitch, because this will damage it and we would need to start it all over again. Here is the technique for laying the turf.
We spread the nourishing multi-purpose topsoil and then fit the trident turf. This is the same turf used at Wembley Stadium and Chelsea Stanford Bridge. We roll it out like carpet, we tamper the edges to ensure it's flat, and then line up to ensure it's all straight.
We then water the area and let nature take its course. finally found a job that I am qualified for.
We left site for a few weeks to allow the lawn and concrete to cure, but simultaneously, the fabrication of the seat frame was taking place. Six to 8mm fillet welds were used to join all of the steel, which is 10mm thick. The main frames were made from 125mm by 75mm angle. Each of these sections weighs roughly 200 kilos. The engineer's design for attaching was an L-shaped 100mm by 100mm bracket welded to each frame. Fixings through the main frames and then bolts locking the frames together. So a mag drill was used to pre-drill all of the holes to assist us with installation. All was then taken to be galvanized and then delivered to site. First, we used timber to support the weight of the frames and get them into position. We then drilled through the pre-drilled holes into the backrest, removed the dust, and applied resin to create a chemical anchor with the bolts. Once these were dry, we fastened the bolts, bolted the frames together, and gave it a lick of paint. The new sundeck was made completely from composite materials. We constructed the support frame first, then moved into place. We excavated, sunk 4x4 posts into the ground, set in concrete, and then fixed the frame to this. This provided stability and elevated the lawn side of the frame, which was lower than the tiles. We then clad in decking. Cladding the seating was one of the most labour-intensive tasks of this entire project. Sapele timber was selected, which is an African hardwood. The factory provided us with 101 1.1 metre by 140mm high by 65mm wide sections and 14 1.1 metre by 140mm high by 140mm wide sections. On site, each and every section needed to be cut at the front and back to accommodate the frame, the length cut down to the correct size, and planed to eliminate sharp edges and achieve a smooth finish. Then, each section was submerged in a wood preserver twice. Once dry, a UV protection satin clear oil was applied. After drying, the process was finished with 2 coats of Osmo oil brushed in. We then mechanically fixed the timbers to the galvanized steel frame. On each of the steps, we have fitted the LED channel on the backside, and we have the light ready, which is going to fit inside this channel. With the majority of work complete, we moved on to the finishing touches. Timber to match the seating was stained, protected, and the kitchen area clad. The fire pit was installed and commissioned. On the front drive, where we accepted material deliveries and stockpile waste, we removed the lawn and fitted synthetic turf. We also did this on both side accesses of the property. And finished off with the tedious task of the top row of mosaic tiles on the pool, which met perfectly with the bullnose paving. Our aim when we started this project was to repair and create sustainable infrastructure which worked with the natural elements and supported natural processes. The alterations required to do this meant the previous work was taken past the point of no return, and as a result, the project needed to evolve. But this gave us the opportunity to increase the collaboration between natural materials and man-made products, some of which were chosen for their structural capabilities and some for their practicality. We blended where we could to limit impact, but in some cases, we wanted to create a unique focal point. And as they say, it is what it is. In total, this work cost Andrew just under £1 million and was 7 weeks in duration, which is unfortunate as this is the second time the works needed to be undertaken. But the beauty of this space now is that it can serve multiple purposes. It can be a family home and at the same time serve its intended purpose to showcase the capabilities of his businesses. Tonight, its intended purpose is the celebration of Andrew's birthday. Thank you for watching. Let us know what your favorite part of the space is and what you think of the work.